Hello everyone, welcome to this lecture. Today we are going to talk about Bernoulli Random variable. The objective is for you to understand what is this variable, how do we compute it, and where is this variable used. So simple concept explained in detail. Let's go ahead and get started. So it's a binary outcome variable. Now when we say binary, it means two, which means this Bernoulli variable is discrete and it can take only two values. And the values are also fixed. It's either 0 or it's 1. Only one of these two values this variable can have. So which variable can have a variable only two values? So something like think this event has occurred or it has not occurred. Okay. Or let's say when you toss a coin, either you will get heads or tails, right? So if you assign some fixed values, 0 will be for tails, 1 will be for heads. Okay? The quality control, 0 for defective item, 1 for non-defective item. So you see, or yes or no questions, okay? Whether you are above 18 or you are below 18. So this is what the Bernoulli random variable is, a variable which can at random take either 0 or 1 value. It is named after Jacob Bernoulli. He was a Swiss mathematician. Okay? So if x is a Bernoulli random variable, then its probability mass function. So how do we compute? So if p of x, probability of p of x is equal to p, then probability of 0 will be 1 minus p. So whatever is the probability of 1, the probability of 0 is 1 minus 1, or 1 minus the probability of having 1, which is generally 50-50. So in either case, so when you toss a coin, right, it would either be heads or it'll only be tails, right? It cannot have a third value. So when you do random twisting of random flipping of coins, 50% of the time you are likely to get heads, 50% of times you are likely to get tails. So that is what here it is for coin toss. But of course, for other questions like yes, no questions, there is not a guarantee that it would be 50-50. It could be 30-70. So what it means is if the probability of 1 is 30%, then the probability of 0 is 1 minus 0.3, which is 70%. Okay, so P is the probability of success and 1 minus P is the probability of failure. Now, where it is used, it's used in modeling binary events, as we said. It is also used in modeling Bernoulli distribution, which is again distribution of events happening or not happening. Okay, it's also included in statistics, probability, and machine learning. It is also used in building more complex models. They serve as the building blocks of more complex models, such as binomial distribution and independent Bernoulli trials, hypothesis testing. Okay, again, to access the significance of observed differences between proportions, quality control, either whether the item is defective or not defective. Machine learning, it's used in machine learning algorithms such as naive Bayes classifiers. So you're classifying, right? So whether it belongs to this category or it does not belong to this category. So to model categorical data, Monte Carlo simulations, in simulations also Bernoulli variables can be used to represent random decisions or binary events, okay? Providing simple and effective models for various probabilistic systems. So wherever you are studying either a probability or trying to prove a hypothesis, wherever the outcome can have only two possible values, there you could use just Bernoulli random variables. So now we know what is Bernoulli random variable, a variable which can randomly assume either 0 or 1. Okay, the probability of, if say let's say the probability of 0 is 0.25, then the probability of 1 will be 1 minus 0.25, which is minus 0.75. So which means if the probability of one outcome is 25%, the probability of the other is 75%. Okay. So for example, let's say a factory produces light bulb. Okay. So each light bulb is either defective or non-defective. So we can define a random variable y to represent y is equal to 1. If the bulb is defective, it's 0, where the bulb is non-defective. So if the factory defect rate is 2, then the probability of the bulb being defective is 0.02 because that is 2%. So that is all about Bernoulli variable. We'll discuss more about the distribution in our next lecture. Until then, happy learning. Thank you all.